All right, class, this is going to be the last video for the semester. I just almost made it with the last video, but, well, there's a little mishap. And here it is. Last part of that problem was to find the present value. So I'm bringing it back on a continuous stream of income. Yes. If we wanted to invest, though, a different amount each year. So not a fixed amount, the 10,000, let's say 1,000 every year, right? As we discussed. But every year a little bit more, and it might be a different kind of function. Who knows? Whatever you are comfortable with, or whatever the company is comfortable with. But we already found the future value, right? Using our integral. Present value, remember, is the same thing. It's the same formula except for, so we call the present value by a PV. And it's going to be the integral for the first 10 years, right? So it's 0 to 10 still. Let's see. We are investing, our function is 1000 T. Yes. This is our CFT times E for the present value means to go back in time. So we have a negative exponent, right? Negative 0.05. Now, as we saw in the previous section, I believe 5.7, if we are investing a constant amount each year, we can easily get by using that the future value, or the amount you're going to get, is the present value, or the money invested, times e to the RT. So this formula here also was valid for a continuous stream of income, where A is your future value, right? So the money you're going to get in the future. P is your present value, the money you need to invest now, e to the RT. Now, this, again, if our continuous stream of income is a constant, and that can easily be proven mathematically. So if you invest the same amount year after year after year, then this formula is going to be valid. However, our CFT is not a constant function, right? It's changing every year. It's changing at a constant rate, but it has a variable in it, right? It's not just every year you invest 1,000, no matter what. Every year you invest 500, no matter what, right? So unfortunately, to find the present value, we are not going to, I should say only. So that's why we could do that in section 5.7, okay? But that's not the case here, so we actually have to go through the motion. So we're going to have to figure out that integral from 0 to 10 of 1000 T e to the negative 0.05 T dt. Okay, so of course, this is chain rule. I'm sorry, a product rule backwards, yes. So we need a U and we need a dV. So we're going to make U, just like in the previous problem, it's very much similar. U is going to be 1000 T. And so out of this, we're finding the derivative. So du is just 1000 times dt. We'll pick the rest of it to be our dV. So if dV is e to the negative 0.05 t dt, then v itself is the integral of it. So the antiderivative of this is the same as e divided by its coefficient. So sure enough, so let me move this up. So sure enough, that's the same. 1 divided by negative 0.05 is negative 20. I think I did that. It's 20, yes. E to the negative 0.05 t. Okay. So going back here, using our formula, right, for partial fraction, for the antiderivatives, yes. integration by parts, then it's going to be the integral of uv is u times v. So where's u? It's 1000 t. U times v. V is negative 20 e to the negative 0.05 t. So it's u times v minus the integral from 0 to 10 of v, so negative 20 e to the negative 0.05 t, v times du, and du is up here, times 1000 dt. So we'll be able to evaluate that, but I'm just going to put this together. 100 times negative 20 is negative 20,000. It's 1,000, not 100. So negative 20,000 t e to the negative 0.05 t minus the antiderivative of this. So the two negatives, here I'll put another negative. Again, that's 20,000 e to the negative 0.05 t divided by negative 0.05. And now this whole thing between 0 and 10. Okay, so we figured that part out. Okay, so going through all the computation, very much the same as the last problem, except for you have to pay attention to a few of the other negatives. And so here you have three negatives, in fact, and those three negatives still are a negative. 20,000 divided by a 0.05 is a 400,000. Evaluated between 0 and 10. Okay, so now plug in a 10. Okay. Okay, so I made t a 10, then gave me another 0 here. 0.05 times 10 is 0.5, and so same thing here. Minus, plug in a 0. I'm not going to do much because once I plug in a 0 in this first term, anything times 0 is 0. Minus 400,000 e to the something times 0 is 0, e to the 0. Okay, so put this in your calculator. That's a negative, by the way, 600,000 e to the negative 0.5 minus is a plus. Again, e to the 0 is equal to 1 plus 400,000. One quick computation, I already did it, is going to give us 36,081.60. So you would have to invest $36,081.60 right now if you wanted to amount to the same value of you putting in 1,000 each year into this account, compounded continuously at 5%. Again, 1,000 T, right? So 1,000 every year, but again, first year 1,000, second year 2,000, and so on, right? So for these present values problems, as you will see in your homework and as we've done, it's about, hey, if I know that this company is going to be returning this sort of amounts to me every year, right? 1,000 the first year, 2,000 the second year, and so on for the first 10 years, then what will be this company worth right now? So this company will be worth $36,081, right? That's, do not pay more for it right now, okay? All right, well, this concludes present value, future value, all the applications, and the whole of the business calculus course. Good luck. Thanks for listening.